Section 2.6 is formalizing relations and functions. Our goal is understand that a function from one set called the domain to another set called the range assigns to each element of the domain one element of the range. On page 135, we have a relation is a pairing of numbers in one set called the domain with numbers in another set called the range. A relation is often represented as a set of ordered pairs x, y. In this case, the domain is a set of x values and the range is a set of y values. A function is a special type of relation in which each value in the domain is paired with exactly one value in the range. So example 1 says identify the domain and range of each relation, represent the relation with a mapping diagram. Is the relation a function? So a reminder that domain is all of our x values, range is all of our y values. They've given us a bunch of coordinate pairs, so we're going to make a mapping diagram and decide whether or not each of these is a function. In our part A, we have the domain is going to be every single x value. So we have -2, 0, 4, and 5. So we can list those in the domain bubble of our mapping diagram. The range will be all of the y values. So we have 0.5, 2.5, 6.5, and since we've already written 2.5, we do not need to write it again. Now we're going to map each pair. So -2 goes to 0.5, 0 goes to 2.5, 4 goes to 6.5, and 5 also goes up to 2.5. Now, on the previous slide, it told us in order to be a function, every single input can only go to one output. So let's double check. -2 only goes to 1, 0 only goes to 1, 4 only goes to 1, and 5 only goes to 1. So this passes. As long as this first bubble, the x's, or the domain, only has one arrow coming from each of them, we're good. So we can say that part A is a function. For part B, our domain is going to be all of the inputs. So we have 6, 4, 6 again, so you only write it once, and 5. For the outputs, we have 5, 3, 4, and 8. So now we're going to map each of these points. We have 6 goes to 5, 4 goes to 3, 6 again goes to 4, and 5 goes to 8. So again, let's check our inputs, our domain. Let's see how many arrows we have coming from each one of these. So 4 only has 1, 5 only has 1. However, if you notice, 6 has a split. 6 goes to 4 and 5. If we want this to be a function, the input can only have one output. So since the input 6 has two outputs, this is not a function. So we would say that part B is not a function because 6 maps to both 4 and 5. Now, what I would like you guys to notice is over here in part A, the range value 2.5 had arrows coming from both 5 and 0. That doesn't matter. It only matters going from the domain to the range. So as long as each of these only has one arrow leaving it, that's good. This next slide has the work for part A and then part B, along with some explanations. And now I would like you to try number 1 on page 135, identify the domain and range of each relation, use a mapping diagram to determine whether the relation is a function.